students, in differential calculus, limits, continuity, differentiability, you are thorough with all the three. In spite of that, you must refer what is differentiability. A function is differentiable at a point x is equal to some point x naught or something like that. Limit x tends to that particular point, that a, let me consider as a, f dash of a, that is limit x tends to a minus f dash of a is equal to limit x tends to a plus, that is f dash of a. If both value occurs same, that means it is differentiability. If not, this is not differentiable. Function may be differentiable, the function may be continued, but sometimes that particular point may not be differentiable. We are going to check for this problem, test the differentiability of the function at this particular point. What point? X is equal to 2. Remember, this is nothing but modulus of x minus 2. You know, it is a familiar term, modulus. What is modulus? Modulus means the value of x, negative value as well positive values. So, but here modulus of x minus 2 means that value x that is less than 2, x minus 2, actually here x minus 2 less than 0, x minus 2 greater than 0. In both cases, we have to check whether it is possible or not. For that only we are going to check with this problem. It is very interesting problem, at the same time so many things we are going to discuss. So, illustration problem. Why it is given in illustration? We are going to analyze the problem in all possible cases. So, first of all, you define the function now. F of x is equal to x minus 2, better you put minus, if x less than 2, if x greater than 2, x minus 2. Dear students, we know that the function is continuous at x is equal to 2, remember that. See the diagram better. Graph of y is equal to modulus of x minus 2. See the diagram. X minus 2 is equal to 0, what happened? X is equal to 2, y is 0. So, this is the point, remember that. This is the point, the curve is like this way, and when you substitute this value 0, that is x is 0, obviously y is modulus of minus 2 obviously becomes 0 comma 2 here like this, and when y is 0, x is equal to 2, so the line is like this way, that is modulus of x minus 2. So, we know that here the function f of x is continuous at x is equal to 2. Now, let us take f dash of 2, that is minus limit x tends to 2 minus f of x minus f of, actually here what else you can think about it, f of x minus f of 2 by x minus 2. Yes, f of x is what else here, limit x tends to 2 minus here 2 minus x, and then here when you substitute it is 0 minus 0 over x minus 2. That means here limit x tends to 2 minus here minus of x minus 2 by x minus 2 getting cancelled, it is nothing but minus 1. This is for f dash of 2 upon this value. Here we have just substituted. Now let us take f dash of 2 upon plus. By the definition, limit x tends to 2 plus f of x minus f of 2 over x minus 2. See, this case you take this value. First one we have taken this and we have substituted. Now for this case we have to take this part. Limit x tends to 2 plus x minus 2 minus 2 minus 2 0 over x minus 2. That means what you have, limit x tends to 2 plus x minus 2 by x minus 2, that means getting answer it is 1, the value is 1, that is 2. Remember, see 1 and 2 here. From 1 and 2 what you can see? From 1 and 2 that f dash of 2 minus is not equal to f dash of 2 plus. So that means what you understand here, they are not equal here. First of all, f dash of 2 minus is not equal to f dash of 2 plus. See, f dash of, that means f dash of x does not exist. F dash of x does not exist. F is not differentiable at x is equal to 2. Remember, it is continuous at x is equal to 2, whereas it is not differentiable at x is equal to 2. The function is continuous, whereas the differentiability, it is not differentiable at x is equal to 2 because of the result what we have. That means all other value, the function is differentiable. All other value mean here x is that other than 2, that means other than the 2 value, everywhere that only the 2 is the value is not differentiable. All other value, the rest, the function is what? Differentiable. Okay. Next point, what does all other points? That means all other points. Let us take points or value, whatever it is, we will consider like that. All other points. So next point, what I can take here, that is very important one. If x naught is not equal to 2. Remember, this is a neighborhood point which I am considering here. Neighborhood point. Neighborhood point means it is very close to that point I am just considering. That is any other point, that is it's not any other point. That is what here, if all other value, all other points, whatever it is, you can say anything. So you may be meaning in different way. So is all other points. Is any other points here, remember. Then what else here? F dash of x naught, remember. Here that word is very important, f dash of x naught. Limit x tends to x naught, x tends to x naught, modulus of x minus x naught by x minus x naught. Will have plus 1 and minus 1 if x is greater than x naught, if x is less than x naught. Remember that very simple way we can define about the neighborhood. So here this point is x is equal to 2. We are testing the condition for x is equal to 2 only. So that means f dash of 2 will have plus 1 as well minus 1 if x greater than 2, if x less than 2. So, that means f dash of x does not exist in everywhere, that does not mean that. Okay. The curve, what about the curve? The curve y is equal to modulus of minus x minus 2, I am sorry, x minus 2, not 1, x minus 2 does not have any tangent line. This point here, this tangent line, common line, that is tangent line means at x is equal to 2, at a point 2 comma 0, at that point, this particular point. That means it is a very close edge, that means the curve here, therefore, the curve has very sharp edge, at x is equal to at 2 comma this point, this sharp edge. This problem is over, but if from this problem what and all you could notice, first of all we have defined the function and we have taken it is a continuous at x is equal to 2, and we have taken the definition and we proved left limit, and we have taken the another definition for right limit 2 plus, and we found out the result. Comparing these two results, and 1 and 2, f dash of 2 minus and f dash of 2 plus does not equal. In that case, that means both the f dash of x does not exist. That means f is not differentiable, not f is, the function is not differentiable at x is equal to 2, whereas the function is continuous at x is equal to 2, and all other points the function is definitely differentiable other than 2, remember that. So, we are taking x is not equal to 2. Suppose I take, since it is a modulus, just we are defining the function for which it is plus 1 and minus 1 for the point. For this 2, we found out the value, that is what we have written. So, the curve, about the curve from this graph, adjoining figure. So, that means the curve y is equal to a modulus of x minus 2 does not have any common tangent at x is equal to 2. Therefore, it has a very sharp edge at 2 comma 0. With this, that continuity, I think, hope you may understand clearly. This kind of problem relatively comes in anywhere else in this topic, you can very well do with the help of these conditions. Remember that how we go for each problem, I think you followed, because this is the fundamental and we found out the result. If you continue to do so, if it is equal, it is exist. Curve may be continuous, but it may not be differentiable. So, this is what the things here. So, see the curve, this curve is continuous, whereas differentiability is not there, whereas this tangent line, common tangent line, we are not getting, that is the main drawback. Otherwise, it would have been a differentiability and continuity will be satisfied. So, it has a sharp, very sharp edge of the point 2 comma 0 in the value of the x axis. So, with this concept, I think you are very clear, and you may go ahead with the remaining problems in the book, and you can also do many number of problems with the idea of this one.